For question 1, it states, Karen rides her bicycle along a straight road from home to school, starting at home at time t equals 0 minutes and arriving at school at time t equals 12 minutes. During the time interval, 0 is less than or equal to t and t is less than or equal to 12 minutes. Her velocity v of t in miles per minute is modeled by the piecewise linear function whose graph is shown above. Find the acceleration of Karen's bicycle at time t equals 7.5 minutes. Indicate units of measure. So in order to find the acceleration in part A, we're going to have to use the equation v prime of x equals v of b minus v of a all over b minus a. This will give us the average acceleration between those two time frames. So we're first going to have to find out what the values of v of a and v of 7 are, and those, if you look at the graph, are 0.2 miles per minute, and the v of 7 is 0.3 miles per minute, not 0.1. That's an error in the writing. And then you divide those by 8 seconds minus 7 seconds, your t values, and you should get negative 0.1 miles per minute squared. Again, that is another error. It is not second squared, it is minute squared. The way I solved for these units was I was dividing a velocity by a time, and the velocity was in miles per minute squared, and the time was in minutes, so you should end up with a unit of miles per minute squared. Using correct units, explain the meaning of the integral of the absolute value of v of t from 0 to 12 in terms of Karen's trip. Find the value of the integral of the absolute value of v of t from 0 to 12. So in part B, we're trying to solve for the total distance Karen traveled in miles from the time frame of 0 minutes to 12 minutes. We can solve for the total distance by finding the integral of the absolute value of v of t from 0 to 12. In this case, we're not given a written v of t, so we have to use the graph to find the distances. So now we must split up the integral to show when Karen is traveling in a positive velocity and when she's traveling in a negative velocity. In this case, it was between 0 to 2 and 4 to 12, she was traveling in a positive velocity, and from 2 to 4, she was traveling in a negative velocity. I found these integrals by first locating the zeros of the function. Then after that, I looked at where the function was, whether the function was above or below the x-axis. Above means a positive velocity, and below means a negative velocity. So now I'm going to explain how I solved those integrals. I did this by using the graph. If you can see from 0 to 2, it is a simple triangle. If you're looking at the function and the x-axis, all you have to do is find the area of that. The same thing goes for the section between 2 and 4. Find the area of that triangle, and that'll give you the total distance from that time period. 4 to 12, is a little bit trickier. It has multiple shapes, but again, you just find the area of those various shapes. From 5 to 6, I found the area of a triangle. From 6 to 7, I found the area of a rectangle. From 7 to 8, I found the area of a rectangle and a triangle. And then from 8 to 11, I found the area of a rectangle. And lastly, from 11 to 12, I found the area of a triangle. So now I'm going through my work. The first interval of 0 to 2, that is the area of a triangle and an absolute value sign. And in the end, I got 0.2 miles from that section. The second integral, it actually should be negative 0.2 times 2 divided by 2 because it is a negative velocity. But because it is in absolute value signs, you end up with a distance of 0.2 miles. And then lastly, I am adding up the various shapes I found in that awkward, kind of strange section from 4 to 12 minutes. In the end, I added those all up, and I got 1.4 miles. And then if you add up those three distances, you should get a total of 1.8 miles. Shortly after leaving home, Karen realizes she has left her calculus homework at home, and she returns to get it. At what time does she turn around to go back home? Give a reason for your answer. So part C states, shortly after leaving home, Karen realizes she left her calculus homework at home, and she returns to get it. At what time does she turn around to go back home? Give a reason for your answer. Okay, so first we have to ask ourselves, what tells you when someone is changing directions? Since we don't have a velocity function, a written velocity function, we're going to have to look at the graph. And something that could tell us when something is changing direction is when there's a change in sign of the velocity. So now we need to ask ourselves, what are we looking for and where is it? Well, if we refer back to the question, it asks, at what time does she turn around to go back home? That back is a key word in letting us know that we're looking for a place when she is changing from a positive direction to a negative direction. Something that would cause this would be a change in positive velocity to negative velocity. So what we're going to search for is a 0 point where the velocity changes from being positive to negative. Since we don't have a written velocity function, we're going to have to refer to the graph to solve this problem. So here's the graph. If you look at the point where t equals 2, you will see that before this, the function is positive, and then following this, the function is negative. So in the end, Karen goes back home when t equals 2 minutes because the function is changing from a positive velocity to a negative velocity. Larry also rides his bicycle along a straight road from home to school in 12 minutes. His velocity is modeled by the function w given by w of t equals pi over 15 times sine pi over 12t, where w of t is in miles per minute for 0 is less than t and t is less than 12 minutes. Who lives closer to school, Karen or Larry? Show the work that leads to your answer. So in part D, we're trying to find the distance it takes for students Larry and Karen to travel to school. To do this, we are going to use the integral of v of t, or the velocity function. This is different from total distance because we're not including the negative direction they're traveling in. It is only the positive direction. So for Larry, he has a written velocity function, which is w of t. W of t equals pi over 15 times sine of pi over 12 times t. We're going to find the integral of w of t from the time period of 0 minutes to 12 minutes. This would be a really tricky problem to do by hand, so it's best to use a calculator in this case. So I'm going to show you next how to use your calculator to solve for an integral. So first you're going to turn on your calculator, then press the math button on the left side. From there, you're going to scroll down to the integral equation and then type in the time interval you're using for your problem. In this case, for us, it's 0 to 12. Then we're going to need to plug in w of t, which again is pi over 15 times sine pi over 12t. Always make sure your parentheses and everything are correct because that can mess up your integral. Then from there, you're going to want to press enter. I got kind of a wacky number, so always check again, parentheses. One thing I do always forget to do is changing my calculator into radians. For Calc AB, you always want to have your calculator in radians. So I enter it again, and I get 1.6. So Larry is 1.6 miles away from school. Okay, so for Karen, we are lucky and are able to use the distances we got in part A. But one thing, we are not using absolute values, so one of the distances will be negative because from one of the integrals, she was traveling in a negative direction. I believe that integral was from 2 minutes to 4 minutes. Oh, it's at part A instead of part A. Okay, part A. So from 0 minutes to 2 minutes, we found out that she had traveled 0.2 miles. From 2 to 4, she had traveled negative 0.2 miles. And lastly, from 4 to 12, Karen had traveled 1.4 miles. So in the end, her house is 1.4 miles away from school, so she is closer to school of the two. If you want more practice with questions like this, I recommend doing the 2 AP questions I suggest below. So first you need to go to your computer and search AP Calc AB FRQ. Then you want to click on the first link that appears. From there, you want to scroll down to 2005 and click on Free Response Questions Form B. On that test, you want to scroll down to number 3 and do that. For the other question, you repeat steps 1 through 2, but this time you scroll down to 2010 and click on free response questions form B. From there, you want to do question number 4.